So far in this Autotrace video series, we've looked at how to run the Autotrace reports and also why you'd use them. In this video, we're going to look at what to expect from the output and how to interpret it. Let's get started. I have here a big SQL statement, which has a correspondingly large execution plan, which we can see in this Autotrace report. So what is it I'm actually looking for in the report? A couple of things. First up, I'm looking at these CR buffer gets and elapsed time columns. Elapsed time, fairly explanatory, how long the step took to execute, and this is in microseconds. Buffer gets is a measure of how much work the step did. The more work it does, so the higher the buffer gets, the longer it's likely for that step to take. Now note that these values are cumulative. We've got this sort aggregate here, which has 79,000 microseconds. However, the sort itself didn't take that long. This is the cumulative total of all the operations below it. The sort itself only took the difference between this value here and the value below it. A similar logic applies when looking at buffer gets. So we want to identify the operations where these have high values. The other thing we want to look for is steps where the value from the cardinality column is significantly different from the value in the last output rows column. Output rows, how many rows were actually returned by this step. Cardinality is how many rows Oracle thinks this step will return. When there's a significant difference between these, an order of magnitude or more, then it's likely that Oracle has chosen a suboptimal execution plan. We need to look for these instances and see if we can get Oracle to improve its cardinality estimates and therefore choose different plans. In an execution plan of this size, it can be difficult to spot which are the problem steps. As we can scroll through, we can see there's a huge amount to look at. Fortunately, in SQL Developer 4.1, there's a new hotspot feature. If we click that, it'll identify for us the places where the cardinality is significantly different to the last output rows. So we got here an example, it's estimating 5, but actually gets 111. And it also looks at the steps which have high run times, so the elapsed time is long. And we can click through and find all these operations. Having identified these, we can now start planning how to change the query to improve its performance.